All right, my little nerdlings, I have to record a quick video for you here to explain law of conservation of mass. You'll get it, you'll pick it up really quickly. The law of conservation of mass is basically a way that it's like a formal way that scientists have said that magic is fake. You can't disappear things or have things just appear out of nowhere. All of the atoms that are in the universe are all the atoms that have ever been in the universe and all the atoms that will ever be in the universe. That's approximately true for at least our purposes here. I think we can say that. So really, we could call it a law of conservation of atoms. That's probably the best way to think about it. It's just that all the atoms that are there in the beginning will be there at the end. So that means that if we add them all, if we put them all on a scale, the mass in the beginning of the whole chunk group of atoms that we're looking at is going to be the same as the mass at the end. That's really what we've got here. So it says that if you write down everything that's there in the beginning and everything that's there at the end, and we separate those things with an arrow in a chemical reaction, we're telling a story here about a chemical change. The stuff that's there before is going to have the same mass as the stuff that's there afterwards. So here, let me move this out of the way. I have a really generic chemical reaction right here. We have some stuff and then some whatchamacallit changes into, here's that arrow. Notice that the arrow is there. That's an important feature I gotta get down here. The arrow is right there. That's it separates before from after. So stuff and whatchamacallit change into thing, and then there's a doohickey and a do job as well, right? What the law of conservation of mass is saying is if I take the mass of the stuff and the whatchamacallit, that total mass is going to be the same as the total mass of anything that's made afterwards. The total inside those boxes must be equal. Here's actually a really good video I would love to have you watch. You can do it. It's only a few minutes long. It's about Antoine Lavoisier, who is the chemist that we most give credit to for discovering the law of conservation of atoms, the law of conservation of mass. This is a quick video about him and his life and his wife and the work that they did together and his death. So there's some nerd love in it. You should check it out. But in any case, these are the kinds of problems that you're going to be asked to do. This is a super simple one, but they don't really ever get much harder than this one. And here we go. So I recommend reading the problem at least twice, right? And this table that I've got here is a way for you to start understanding these problems. You won't need it for very long, but if you ever get in a sticky one, I would come back and I would use one of these tables again. This is the way I teach it to other students who are maybe not quite as able as you are. So if we read this, from a laboratory process designed to separate water into hydrogen and oxygen gas, a student collected 10 grams of hydrogen and 79.4 grams of oxygen. How much water was originally involved in the process? Here's the deal. Let's read it again a second time here, and let's put names in for what's there before and after. It says, from a laboratory process designed to separate water into hydrogen and oxygen. That word into is almost like the arrow in our chemical reaction. I think that we have got water in the beginning, and afterwards we have got hydrogen and oxygen, right? So on our second reading, we try and pick out the names of the things that are there before and after, something that you should be aware of, especially in a couple of the problems that you're going to do in your problem set, and certainly in ones that are more challenging. Sometimes there'll be leftovers, what we call them. And so something could be there both before and there could be leftovers there afterwards. You should write it on both sides in that case. In this process, we have water separated into hydrogen and oxygen. Now let's look and read it again and put numbers on. It says it separates water into hydrogen and oxygen gas. A student collected 10 grams of hydrogen, so I'm going to write 10 grams right underneath where I wrote hydrogen, and 79.4 grams of oxygen. And question is asking me how much water was originally involved in the process. Okay, so the key here is for you to understand that this is basically a math equation now, and it's very simple algebra. It's just adding and subtracting, right? The mass in the beginning has to be equal to the mass on the end. Put an equal sign in the middle there. So we're just going to add together the stuff that's afterwards, and that's going to be the mass of the water that we had. It should be 89.4 grams of water. Again, some of the harder ones involve leftovers. If you have leftovers, something that's not completely used up, it should be both in the beginning, the before part, and in the after part. Use tables like this one to help you if you get in a situation where you're not quite sure. I would always recommend organizing your thoughts this way. All right, so give it a try. Your homework is to do problem set 5.2, and we'll have a look at it tomorrow. Thanks, guys.